Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 8 we are going to discuss about dimensional analysis method in which that is a topic given in your textbook, that is 1.4.3. Now, what is the use? Why we need this dimensional analysis method, that we are going to discuss first, right? So, most of the time while calculating, it is written here, often while calculating there is a need of converting unit from one system to other. Means, what is the meaning of that? Suppose we have a unit in centimeter, I need to convert it into inch or into feet also, suppose. Right? So, when I want to convert this, there is a very easy technique, what we use or what we call it as dimensional analysis method. Understood? So, what is dimensional analysis method? It is just for converting unit into from one system to the other system. Understood? So, you can write down this, what is the need of what we call it as converting this. Okay, so this method, I think this part will be clear. Now, this was being left out when we discuss certain topics like significant figures and all. Understood? So that's why we are going to discuss today this method. With examples I will explain that. Now what is the need that I already explained here? Now the method is used, this method is used to convert one system into another unit, what we call. So it is called dimensional analysis method. Another name is also there for this method. That is, you can see here, factor label method or unit factor method. Okay. So now we will explain it through an example. Okay, just a minute. Okay, now you can see here one example is given in your textbook. If you see a piece of 3 inch, that is represented by IN for inch, what we call long. What is the length in centimeter? Understood? So there is one technique in dimensional analysis method, that is how to use that method. So it is very easy. Whatever answer you want in, that is, I want the answer in this unit, that is centimeter, will always be written in the numerator part. Now, what is the meaning of that? You can understand by this example. Now, before that, we know 1 inch, this all things you must know formula. 1 inch is equal to 2.54 centimeter, what we call. Understood? Now, our question is what? 3 inch has to be converted into centimeter. This is our question, what we say. Now how to convert? So we are going to use this method, that is dimensional analysis method, what we say. Okay. Now how to do so? See, now 3 inch is there, 3 inch. I will multiply it with a fraction. Fraction means what? Now suppose centimeter answer I want. So 1 inch is equal to 2.54 centimeter. So what I will do? I will write here 2.54 centimeter upon like this 1 inch. Means 1 inch is equal to 2.54 centimeter. You write like this. Means what is the meaning of that? Now suppose you want answer in centimeter. So whatever is the formula, that centimeter part will always be in the numerator. Understood this part? Where it will be in the numerator. So now what will happen in this case? Say here you can see. Okay, you can see here inch and inch will get cancelled, the unit. So what is remaining? 3 into 2.54, and what is remaining now? Centimeter. So if you calculate this, if you multiply this, you will get it is equal to suppose 7.62 centimeter. How much it will be? 7.62 centimeter. So this is our dimensional analysis method. One more example I will be showing you for this, a little bit more complex, what we say. Understood? But this part you always remember that whatever answer you want as a unit must be always written in the numerator. Where to be written in the numerator? Understood this part? Now the second example. Just a minute. Now here you can see the second example. What is written here? Example 2. This both example you have to write it in your fair book. Now pay attention. A jug contains 2 liters of milk. Calculate the volume in meter cube. Means, what is the meaning of that? What is your question actually? 2 liters, you have to convert it into meter cube like this. But before that, you must know one formula. Now, what is that formula? That is 1 ml is equal to 1 centimeter cube, or also can call it as 1 cc, like this. Understood? Now we know that 1 liter is equal to 1000 ml, what we have studied in our lower classes. Okay, so 1 liter is equal to 1000 ml, so 1 ml is equal to 1 centimeter cube. So can I write 1 liter is equal to 1000 centimeter cube, like this? Because 1 ml is equal to 1 centimeter, so 1000 ml is equal to 1000 centimeter cube. Understood this part? Or also you can write this as 1 liter is equal to 1000 means what? How many zeros? 3 zeros. So 10 raised to 3 centimeter cube. Okay. So this is the formula one you have to remember. Okay. Now this is one formula. Okay. One part. Second part, when we say the second part. This is first part what you have to remember. Now the second part. We know 1 meter is equal to 100 centimeter. Now we have to convert this into meter cube. So if I write 1 meter cube, 1 meter cube means what? 1 meter into 1 meter into 1 meter is equal to 100 centimeter into 100 centimeter into 100 centimeter. 3 times what we say, right? So this will be equal to 1 meter cube, 1 into 1 into 1 is 1, is equal to, now this total 6 zeros are there. So what I write? 10 raised to 6 centimeter cube. So this is the second formula what I will be using for the calculation. Understood? So these two things. So these are the main parts of this dimension analysis. In these formulas you must know. Understood? So now the next part what we say here, I think you can see space is there. Okay. So what is the word first? Or I will rub this part. Okay, so that you will do it in one single step only. Okay, just a minute. Now these two formulas we are going to use. Now what we will do first, we will take this 2 liter I need to convert. So I can write 2 liter into, now which formula I will use where the liter is there. So what? 1 liter is equal to 10 raised to 3 centimeter cube. Now after cancellation I must get meter cube. So what I will do? This liter, what is this formula? I will write like this, that is 1 liter is equal to 10 raised to 3 what? Centimeter cube. Understood this part? Okay, this part is clear. Now multiply by the second formula. See, here centimeter cube is there. So if I want to cancel, where I will take this centimeter cube? Obviously in the denominator. So 10 raised to 6 centimeter cube this over, and this 1 meter cube will be here. So 1 meter cube, because we want answer in meter cube, that's why I have written it in numerator. This part is written in where? Numerator. So always choose this wisely. So it will be very easy for you to calculate. Now what to do? Very simple. Liter will get cancelled. Centimeter cube, units I am talking about get cancelled. Now what is remaining? So you can see here, that is 2 into 10 raised to 3 into 1 upon 10 raised to 6, like this what I am talking about. Okay, so now I think you know this identity is what to do. So I will just subtract this. So what it will be? 2 into 6 is there. So if I take this 6 on in numerator, it will be negative. So 10 raised to 3 minus 6. So what it will be? Which is equal to 2 into 10 raised to minus 3, like this. Okay. Now what is the unit left out here? So that is your meter cube what we write. Understood? So what we say here? 2 liter is converted into meter cube in this case. Okay. Now if you see in your book also, you can see this example is given and we got the answer. So this is the dimensional analysis method what we say. Okay. If you want more examples, we will be discussing in the next videos. Okay. Just a minute. Okay. Now here you can see one third example. What is the question? How many days are there in, how many seconds are there in 2 days what is given? Now what is the meaning of that? Means this 2 days, that is the question, has to be converted into seconds. What has to be converted into seconds? So you must know the formula. Now we will use 3 formulas here. We know 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. Clear? And 1 minute is equal to 60 seconds. So these are the three formulas we are going to use to convert this. That is our dimensional analysis method, what we say. So first I will write here 2 days. Now which formula contains days here? So here, right? So into what I write, 1 day is equal to 24 hours, what we say. Now why I took this day here, so that I can cancel it easily. Then another one to cancel day, I will use this. Now 1 day is equal to 24 hours. So hour 1 now here it is. So what I write here, 1 hour is equal to 60 minutes. Understood? And we can write here, now minute is there. I want answer in seconds. So second must be written where? In the numerator. So what will come here? 60 seconds. That is 1 minute is equal to 60 seconds, what we say. Understood? Now you can see very easily you can cancel. This days got cancelled, minute got cancelled, and hours got cancelled. Understood? So now what is remaining? Only one unit, that is our second unit. So the numbers now you can add here. That is 2 into 24 into 60 into 60. Right? And here seconds, what we say. Understood? So now if you calculate this, you will get, it will equal to 172800 seconds. Seconds, one symbol is there. Lowercase s is written here. Understood? So this is the part what I am talking about. So this is our dimensional analysis method. Now in your textbook exercise, there are questions given based on this. So you can go through it, but that I also will be solving in our next videos. Understood? Okay? Next. Okay. Now, this is the next topic what we are going to discuss, that is topic 1.8, mole concept and molar masses. Understood? Now, before that, mole concept definition you have to understand what is the meaning of that. See, one mole is the amount of substance that contain, it's the amount what we say, of substance that contain as many as particles or entities. Particles means it can be atoms, it can be electrons, it can be molecules, like that what we say, okay, entities. As there are atoms in exactly, now this is the important part, exactly 12 gram of the C12 isotope. Clear? So 1 mole is equal to how many atoms, molecules or electrons, whatever what we say, present in the 12 gram of C12 atom. Now, through mass spectrometer technique. Now mass spectrometer technique is used to measure the mass of an atom. So by mass spectrometer technique, C12 isotope, the atom, that is one single atom of C12 isotope weight was equal to how much? 1.992648 into 10 raised to minus 3 gram. Okay, this is for one atom. But how much gram is of carbon, what we say? Carbon atom is of 12 grams. Understood? So, if one atom, pay attention here, this is atom and this is gram. Understood? So, one atom weight is what? One I am talking about. What atom of what? Carbon, C12 carbon atom. One atom contains weight 1.992648 into 10 raised to minus 23 gram, what we say. Understood or not? So, how many gram it is of carbon? So, carbon is of how much gram? 12 gram. So, 12 gram carbon contains how much atoms? Understood? So, therefore, number of atoms in 1 mole will be equal to what I will do? What it will be? 12 into 1, opposite, this cross multiplication technique. 12 into 1 divided by 1.992648 into 10 raised to minus 23. Understood or not? So after calculation we came to know that the entity, I think you can see here, the entity value after calculation of this was equal to 6.022 into 10 raised to 23 atoms. What we say? What? 23 atoms. So now, if you see here, that is, this part I think you must have understood now. How much it is? 6.022 into 10 raised to 23 atoms. That is 1 mole of this atom. 1 mole is equal to 6.022 into 10 raised to 23 atom. Because carbon is taken as standard for finding out atomic mass, molecular mass. We have seen in our previous videos, if you have seen. that is atomic mass unit what I explained, based on fruit mass unit I explained. Okay, so here 1 mole is equal to how many atoms? 6.022 for your convenience. Actually it's a bigger number, but you can remember like this, into 10 raised to 23 atoms. If we talk about molecules, it will be molecules. If we talk about electrons, it will be electrons. It will be like ions or many things what we can say, because this we have seen in the definition. Particles or entities what we say. Okay, now furthermore this concept I will elaborate, I will explain it in more. Okay, now next part, see. Okay. Now you can see here 1 mole is exactly this number what is actually what is it, but for your convenience we write like this, that is 1 mole is equal to 6.022 into 10 raised to 23 what we say, because rounding off what we say like that at this place. Okay, so now 1 mole is equal to, it can be this many atoms. When you talk about atoms, it can be this many molecules when we talk about molecules, and this many particles, electrons, neutrons, all that what we have, if we talk about that part. Okay, so 1 mole is equal to, this is the number what we say. Okay, now this is given a special name if you remember in the what we call honor of a scientist, Avogadro what we call, and this is also called Avogadro's constant. This is also called what? Avogadro's constant, and the symbol for this is given like this, Na. It is written like this. So this is your Avogadro's constant, what we call it as 1 mole. Okay. Now what is how to identify? Now when I am talking about atoms, understood? Now see here, atoms. Now suppose for your convenience we will take this we understood already. So we will take one another atom. Suppose sodium atom if I take. Now which atom? Sodium. Na means which atom? Sodium atom. Always remember, whenever 2 letters are there for a symbol, first letter should be in uppercase and second letter should be in lowercase. Understood this part? Okay. So this sodium atom I am going to talk about. Now we know from that what we say mass spectrometer. Okay. Mass of sodium atom, that is atomic mass. What is the word? Atomic mass of sodium. Sodium was found to be 23 U. Remember this thing. How much U? 20. U means unified mass. So now suppose if I convert this unified mass into grams, that is if I take 23 grams of Na. Okay. Now suppose we will start with U only. Suppose if I take 23 U of sodium, it will be equal to only 1 atom of sodium. Understood? So if I am talking about unified mass, it will contain only 1 atom of sodium. But if I convert this unified mass into grams, that is 25 grams of Na if I take. Understood? Means gram atomic mass I have converted into. We have seen the definition in our previous video. So if I convert this into gram atomic mass, that is 23U, I converted into what? Grams. It will be equal to how many atoms? So 6.022 into 10 raised to 23 atoms of sodium. Just imagine how much big is the number. 10 raised to 23 means what? With 1 there are 23 zeros. Clear? Your brain will stop working if you think of this. But better you remember this number. That is easy for you. So 23 grams of sodium contain how many atoms? This many atoms. So this I was talking about what? Atoms, and I took their atomic mass what we say. Now one more example I will give based on atoms. Just a minute. Okay. Now second example based on this for atoms. Atoms. The second example will be of calcium. Calcium atomic mass of calcium is equal to 40 U what we say. Understood? Now the before example which I gave previously, that is of sodium, you can write down in your fair book to understand this mole concept. Always remember 1 mole is equal to this many entities what we say, or particles or atoms like that. When I am talking about atoms, I will be discussing about this many atoms. Okay. So now suppose here you can see calcium. So calcium, this is how many? What is this? Atomic mass. Always remember, don't take atomic number. You have to take atomic mass for calculating the moles related numericals. Understood this part? So calcium if I take here 40U. 40U means what? 40U of calcium is equal to 1 atom of calcium. Understood? Remember this thing. If it is U, whatever atomic mass, that if it is in U, unified mass, it contains 1 atom of calcium. But if this U, if I convert it into gram atomic mass, that is 40 grams of calcium will contain how many atoms? So it will contain 6.022 into 10 raised to 23 atoms of calcium, what we say. So understood? These are the two examples what I gave for what? What are these examples for? Atoms I am talking about. Okay, so when I am talking of atom, this many atoms will be there. When I am talking now, the next example what I am going to give is about molecules. Okay, so the next part, see. Okay, now we are going to take an example of a molecule, what we say. Okay, now in molecules I will take example of water. Water molecule I will take. Okay, so water, if I find the molecular mass of water, so that is equal to H2O, what we say, is equal to 2 into 1 plus 1 into 16, that is equal to 18U, what we say. Understood? So when I say 18U of H2O is equal to 1 molecule. What is the word? 1 molecule of water. It contains only 1 molecule of water. Understood? So now suppose if I convert this into gram molecular mass. So 18U converted into what? 18 gram of H2O will be equal to how many molecules of water? So 6.022 into 10 raised to 23. Here what will come now? Molecules will come. What will come? Molecules. Understood? 23 molecules of H2O will be there. Means if you weigh 18 grams, suppose if you are drinking water at home, and suppose in that 1 glass of water there are 18 grams of water. If you measure them, first empty glass you measure and then pour water and measure and subtract it, so you get the exact mass of water. So suppose the water mass is 18 gram. Okay, so that 18 gram water contains how many molecules? So 6.022 into 10 raised to 23 molecules. So now from at home, suppose you go and suppose if it is 100 gram water is there, you can calculate the molecules of that water and tell your mother or your what you call brother, sister, you can tell, give me this many molecules of water. First they will think that you have gone mad, but actually now you know the concept of what we call molecules. So this is the part what I am talking about, means you can now calculate the molecules of water in a glass of water, what we say. Okay, just measure the actual mass of water, you can easily calculate, because 18 gram contains this many molecules. So suppose your water that is in the glass, if water is there, that is of 100 gram, so 100 gram how much molecules? You can do easy cross multiplication. Understood? So this was all about mole concept. Always remember and always respect this person, that is Emilio Avogadro, who gave this constant, because it is not a very easy part what we see. It is a very huge number. You cannot even what we call tell the actual value of this number also. Okay, so 1 mole is equal to 6.022 into 10 raised to 23 species entities particles, what we say, and it is also called Avogadro's constant. Its symbol is Na. Today we discuss about mole concept. We also discuss about based on atoms and based on molecule. So these all things you can write down in your fair books, what we say. Okay, so the next topic what I am going to discuss is about percentage composition. Okay, that is the next topic after this mole concept. Okay, just a minute. Now before going to the next topic, one more example we will go through, so that this topic, that is the concept, mole concept, will be clear to you. Understood? Now you can see here the question is, calculate the number of molecules present in 22 grams of, the word is what? Number of molecules you have to find in 22 grams of CO2. So first of all we will find molecular mass. What is the word? Molecular weight or molecular mass of CO2. So molecular mass of CO2 means atomic mass of CO2 is 12. Nothing is there into 1 plus 2 into 16, what we say. Understood? So if you see, it will be what? 44U, what we say. Understood? So this is unified mass. Now for calculating molecules and for using mole concept, you have to convert this unified mass into grams, what we say. So I can say that 44 grams of CO2, or otherwise first from beginning we will start. 44U of CO2 will be equal to 1 molecule, will be equal to 1 molecule of CO2. Why? Because here U is there. Now this 44U, if I convert it into grams, so 44 grams of CO2 is equal to, I can say, 6.022 into 10 raised to 23 molecules of CO2. Now the question is asked, that is, in 44 grams, this many molecules are there. So 22 grams of CO2, how many number of molecules? So what we will do? I will write here, in mere grams, I write this grams. 22 grams of CO2 is equal to how much? So simple cross multiplication it is. Simple cross multiplication. Therefore, number of molecules in 22 gram of CO2 is equal to what it will be? 22 into 6.022 into 10 raised to 23 divided by 44, like this what we say. Understood or not? So this is simple cross multiplication what we say. Understood? So it will be equal to, you can simply cancel this, 22 ones are and 22 twos are. So 6.022 into 10 raised to 23 divided by 2. Okay, so now that will be, I'll just write it on the top, I think you can see or not. I'll write here, and that is equal to, if you just calculate, that will be equal to 3.011 into 10 raised to 23 molecules. Understood? So this one also you can write down in your fair book as an example of mole concept. Okay? So this is the way you can calculate molecules also, you can calculate atoms also, but when you calculate atoms you have to use atomic mass. When you calculate molecules you have to use molecular mass. Okay? This is the main part what we have to remember. Okay? Next. Okay. Now here we will stop this video because it is already of 27 minutes. It is a bigger video what we call. Okay, so whatever things discussed in this video, you can go through it. Please write it down in your fair book, okay, and go through your textbook thoroughly. Okay, so this one till here we will stop. In the next video, we will be discussing about that is video 9. We will be discussing about percentage composition and empirical formula. Okay, empirical formula for molecular formula. How to derive that? What that only we are going to discuss in the next video. So till then, thank you very much. Okay, and keep reading. Okay.